All right, so now we're generalizing uh, the work that we did above. All right. Let's see. From the work we did above, let's see, we had something like this, right? We had A and B, X, Y, Z, 20, and 30, something like this. Little dots here. And how many dots are there, right? You can just count them. 1, 2, 3, 4, 5, 6, right? But why is there 6, right? It's because for each x coordinate, or I guess for each a coordinate in this case, for each coordinate along for each element of a, each element of a is associated with 2 elements of b. Each element of y, so y is associated with 2 elements of b. Z is associated with 2 elements of b. So above, right? And this is not the answer here, right? Because here we have m elements, n elements. We're generalizing what we did above. But in any case, let me just write that. Let's say for part A, this equals all right, so two times 3, which is 6. All right, now something I should just mention. Now, I guess maybe don't quote me on this, but the way I think of it, and this is true, I mean, I'm telling you real things here. The way I think of it is, when we say 2 times 3, it's you're adding 2 3 times, right? 2 times 3 is really 2 plus 2 plus 2, right? And that's exactly what we have right here. So you have 2 things, 2 things, and 2 things, plus and plus, 2 plus 2 plus 2, right? Yep. And also, right, another way of looking at that is you have 3 things 2 times, right? So this is 3 plus 3. So think about how you'd say that. You would say, so 3 times 2 is you have 3 2 times, which happens to be 6. Right, so anyway, I think you probably see that it is 2 times 3 or 3 times 2, same thing, equal to 6. But that's a good explanation. I have your attention, so figured I should just mention a little bit about 2 times 3 being the same as 3 times 2. That's why. Okay. Yeah. All right. So now again, let's generalize what we just did right there. Right. So we have A. We have B. Let's say that A is the set A1, A2, AM, right? Why the M there, right? Because, let's see, M and M right there. Okay, and then B has the set B1, B2, Bn. Right, so there's the n, there's the n there. Right. Okay, let's see. Like that. Okay, so A1, A2, AM, B1, B2, Bn, and we have all these points, right? So we'll draw these a little bigger to emphasize that they're points. And the little dots are meaning that this just goes on and on and on until you get to there. Right, and this whole thing is just going on. Oh, you know, okay. Dot, 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 dot. Okay. All right, so let's see. Let's just use the red. So like that. Mm-hmm. All right, so you have, let's see, how many, for each A1, how many do you have of these points, right? There's n of these, n of these, n of these, right? Because we can count them, right? Let's see. 1, 2, dot, 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 n, right? So we counted n of these, right? So you have n written m times, which is the same, right? As writing m things n times, m n times. So the answer is m times n. Now, perhaps you might be saying, I want to see a proof of this, right? Which is, which is a good thing to ask for, especially from a mathematician in a math class. Say, can you prove it? If you were in class with a mathematician and you wanted to keep him from actually getting to the material or something, so you might get an extra day before the test or something, you might ask him to prove a bunch of things that he really likes to talk about, and then he'll just prove them all class. And then you won't have to take the quiz. Shoot. All right, so, okay, I don't know why I'm doing this, really. Your proof, really, I basically just proved it. This is the proof.